Today, we embark on a journey into the fascinating world of transportation planning, where the intricate interplay between mobility, sustainability, and urban development shapes the way we move within and between cities. Over the next few minutes, we'll explore the foundational concepts that underpin this dynamic field and lay the groundwork for deeper discussions on demand modeling and trip generation. Transportation planning is far more than a mere series of decisions. It's a multifaceted process that begins with a vision for a more connected and sustainable future. From articulating goals to assessing opportunities and constraints, we navigate a landscape rich with challenges and possibilities. Key themes such as sustainable mobility and the symbiotic relationship between land use and transportation planning guide our exploration. We delve into diverse approaches, from supply management to demand management, that offer innovative solutions to transportation issues, fostering inclusive and resilient communities. At the heart of transportation planning lies the concept of derived demand, the understanding that people don't travel for the sake of traveling but to engage in activities. This pivotal insight informs our analysis of travel patterns and helps us anticipate future mobility needs. A comprehensive four-step modeling framework serves as our compass, enabling us to predict future travel patterns and assess the impacts of proposed developments on transportation infrastructure. Through this lens, we gain valuable insights into the dynamics of urban mobility and infrastructure planning. As we embark on this journey, we lay the foundation for deeper exploration into trip generation, distribution, mode choice, and assignment. Each step forward brings us closer to understanding the intricate web of factors that shape our city's transportation systems. In closing, I invite you to join me in unraveling the complexities of transportation planning, as we strive to create more sustainable, equitable, and connected communities for generations to come.
Transport modeling typically involves a four-step process, known as the four-step model. Here's an overview. Trip generation. This step focuses on understanding the generation of trips, which are essentially movements of people or goods from one location to another. It involves determining the number of trips produced in each zone, such as residential areas, and attracted to each zone, such as commercial areas, within the study area. Factors influencing trip generation include population, employment, land use, demographics, and socio-economic characteristics. Trip generation is a fundamental step in transportation planning that involves predicting the number of trips originating from or destined for a particular area. This process helps planners understand the travel demand in different regions and is crucial for developing efficient transportation systems. Here's a breakdown of what trip generation entails. 1. Data collection. Gathering data on land use, population, employment, and socio-economic characteristics of the area. 2. Modeling. Using mathematical models to estimate the number of trips generated. These models often consider factors like household size, income, car ownership, and land use types. 3. Analysis. Assessing the trip production, trips originating from a location, and trip attraction, trips destined to a location. 4. Forecasting. Projecting future trip generation based on expected changes in land use, population growth, and economic development. The output of trip generation analysis is used in subsequent steps of transport planning, such as trip distribution, mode choice, and route assignment, to design and improve transportation infrastructure and services. Next we look at the trip distribution process of the four-step model. Once trips are generated, the next step is to distribute them spatially across the transportation network. Imagine a city divided into zones. While trip generation estimates the number of trips originating in each zone, for purposes like work or shopping. Trip distribution then figures out where those trips are headed. It assigns these trips to destination zones. This process considers factors like zone attractiveness, travel time, and travel cost. Zone attractiveness refers to how many trips a zone is likely to attract. It's essentially a measure of a zone's pull on travelers. Some of the factors influencing attractiveness are land use. Zones with a mix of land uses such as residential, commercial and office tend to be more attractive because they offer various trip purposes such as work, shopping, and errands. Job density. Zones with a high concentration of jobs attract work trips. More jobs generally mean more potential destinations for people. Amenities. Zones with a variety of amenities like schools, hospitals, entertainment options, etc., attract trips for various purposes. Accessibility. Zones with good access to public transportation or major roads are generally more attractive as they're easier to reach. Uniqueness. Zones with unique features like major shopping centers or tourist attractions attract trips from a wider area, even if they're not as close. The result is a trip table showing the number of trips between each zone pair. This data helps transportation planners understand travel patterns and optimize infrastructure like roads and public transport. Next we talk about modal split or mode choice. Modal split, also known as mode choice, refers to the process of determining the proportion of travelers using different types of transportation modes, example car, bus, train, bicycle, walking, for their trips. It assesses how people choose among available transportation options based on various factors. Several factors can influence an individual's choice of transportation mode, including travel time or the duration of the trip using different modes. Cost. The monetary cost associated with each mode, including fares, fuel, parking fees, and maintenance. Convenience and comfort. Factors such as the frequency of service, availability of seats, cleanliness, and overall comfort. Accessibility. How easily travelers can access different modes, including the proximity of transit stops or stations. Reliability. The consistency and dependability of the service, including punctuality and service interruptions. Safety and security. The perceived and actual safety of using each mode, including accident rates and crime levels. Environmental concerns. Awareness and attitudes towards environmental impact, leading some to choose more sustainable modes like cycling or public transit. Socioeconomic factors. Income, age, gender, and car ownership can also influence mode choice. Finally, we talk about trip assignment. Trip assignment. The final step assigns the trips to specific routes within the transportation network. It involves determining which roads, public transit lines, or pathways travelers will use to reach their destinations. This step often involves traffic assignment algorithms that consider factors such as travel time, congestion, capacity constraints, and network connectivity. These steps are iterative and interconnected, meaning that adjustments made in one step can influence the outcomes of subsequent steps. In conclusion, transport models help planners and policymakers understand current travel patterns, forecast future demand, evaluate the impacts of proposed transportation projects or policies, and identify strategies to improve transportation systems' efficiency and sustainability. As we conclude our exploration of the four-step models in transport modeling, I would like to take a moment to reflect on the significance of this powerful framework. The four-step model comprising trip generation, trip distribution, mode choice, and route assignment provides us with a robust tool to understand and predict travel behavior. By breaking down the complexities of transportation into these distinct steps, we can better plan, design, and manage our transportation systems. We've seen how trip generation helps us identify the origin and destination of travel, trip distribution shows us the connection between different locations, mode choice offers insights into travelers' preferences, and route assignment determines the paths taken by travelers. Each step, while unique, contributes to a comprehensive understanding of travel patterns and behaviors. The application of these models extends beyond mere theoretical exercises. They are integral to urban planning, policy making, and infrastructure development. By accurately forecasting travel demand, we can make informed decisions that enhance mobility, reduce congestion, and promote sustainability. As we move forward, let us continue to refine these models, integrating new data sources and leveraging advanced technologies. The future of transport modeling holds immense potential, with opportunities to create smarter, more efficient, and more sustainable transportation networks. Thank you for your attention throughout this presentation. I hope you found the insights valuable and that they inspire you to further explore and contribute to the field of transport modeling.